Here's a size comparison of Titan and the Earth. You can see that the Earth is smaller than Titan, but it is bigger than the Moon. So the first thing I want everyone to know is that Titan is a moon of Saturn. You can all remember that, I'll be happy. And so I just said that its radius is about 4,500 kilometers, a bit less than half of Earth. The distance from the Sun is 10 times the distance of the Earth from the Sun. And it's orbiting Saturn, so that's actually the same distance that Saturn is from the Sun. The obliquity is 27 degrees about, and that's a bit more than Earth. And what does that mean? That means that Titan is inclined to... Can everyone hear me? So it's tilted with respect to the Sun to its orbit, which means that there's going to be seasons, just like on Earth. And the orbit around the Sun is 30 years long, which means that the year of Titan is 30 years long, Earth years, which means that the seasons are going to take that long to happen. And that also means that we've actually only observed 2 seasons so far close up on Titan, so we don't really know what happens during northern winter. And the next thing to know is that the day of Titan is 16 days long, and the surface gravity is 0.14 g, and the g is gravity on the surface of Earth, and so that's a really small gravity because the planet is so small. So Titan was discovered in 1655 by Christian Huygens, and for a very long time, all we knew about it is that there's a big orange ball, and we couldn't see anything on the surface because the atmosphere is so thick that in the visible wavelength, you can't actually see the surface. So this is what Titan looks like if you look at it with your eyes. And but the Cassini-Huygens mission, which is super awesome, has been orbiting the Saturn system since 2004, has instruments that can enable us to know what the surface of the Titan looks like, and this is what it looks like in the infrared. And you can finally see that there is interesting stuff on the surface. Now, the Cassini-Huygens mission is this really cool mission, and I'm only going to talk about 3 of the instruments because they're the instruments that give us all the cool images for Titan. So, the radar basically sends light at 2 centimeters wavelength to the surface, and then measures the light that comes back. So in altimetry, it measures the light that comes back straight down, and in SAR, which is synthetic aperture radar, it measures the light that comes off to the side, and that helps them. With SAR, you can make images of the surface with very high resolution, 300 meter per pixel resolution. And then VIMS is basically an IR camera, an infrared camera, and ISS is a visible and slightly near-infrared camera. So I have my first trivia question now. How cool is Titan's surface?
Super cool.
That's what I think too. But how super cool?
Raise your hand if you think you know the answer.
B. That is correct. B is the right answer. And yes, that's because A is actually below absolute zero, so minus 461 Fahrenheit is actually impossible. And C is the mean temperature on Mars' surface, and D is just a cold day, but not here because here it's warm, or further up north. So this is the actual surface, so now you can see it is cool. And here the background is ISS, so it's near infrared. And the strips that you see like that going around are SAR. Now, why do they have this weird shape when you see strips of data that are high resolution like that? That's because each time that Cassini, the spacecraft, goes near Titan, it just comes from far away, it goes close, and then it goes far away again. So as it's going nearby, it's going to take data just underneath it and then go away. So each time you're going to get a strip of data like that. And each time you do that, you get this map. So the first, now I'm going to get to the really cool stuff now. The first really cool thing is that it's the only moon with a planet-like atmosphere. So it actually has a very thick atmosphere, thicker than Earth's because the gravity is so small that the atmosphere extends further. And this is the only nitrogen-rich atmosphere apart from Earth. So Earth has like 75% nitrogen, and Titan has more than 95% nitrogen. And the rest is mostly methane. Now the surface pressure on Titan is 1.4 bars, a bit more than Earth. And the interesting thing about that is that at 93 Kelvin, which is the surface temperature, and 1.4 bars, methane, which is abundant on Titan, can be either liquid or a gas. What does that mean? It means that there could be liquid methane on Titan, which is super exciting. And now if you look at it, you can see actual clouds of methane that are just, this is an infrared image, and the clouds are bright, and you can see them going around the planet. And this is actually a big storm that made rain, and indeed it rains on Titan. And so this is how we can prove that it rains. It's by observing the same spot many times. So these are all infrared images. And in the first one, you can see that you have an interesting landscape. In the second one, you can see a bit of clouds. And in the third one, you can see a lot of the landscape is very dark. And that's because the ground is wet because of the rain. And just like wet ground is dark on Earth, the same thing happens on Titan. And this actually stayed wet for more than a month before it actually dried out. So this is the proof that it rains on Titan. And now we can also prove that there is liquid methane, not water, on Titan. And here you can see a sun glint. Basically, the light from the sun is reflecting off of the liquids and is directly visible to the spacecraft. And you can see the same thing with liquids on Earth. And that's super exciting because it means there's standing liquids on Titan, which means that Titan is the only object other than the Earth in the solar system that has standing liquids on the surface. And these liquids are going to make seas and rivers like this. And this is like Lea Bonnefoy, which you can compare to Lake Mead, where Lake Hoover Dam is just at the bottom of that image there. And you can see that it looks kind of the same, and that's because it is basically the same process. Here, Lake Lea Bonnefoy is formed by recently raising sea levels that kind of flood the surrounding terrain, which is the same thing that happens there on Earth. And the reason that you see, so this is a SAR image, a radar image, and the reason that Lea Bonnefoy is dark there is because these liquid methane is very smooth and absorbing, so the radar light is going to either is going to be absorbed by it and be scattered off in a direction that is invisible to the radar. So here's a very weird thing that has been observed by the Cassini mission. So here the dark part of each image is the sea, it's like Lea Bonnefoy again, and the bright part is just the surrounding terrain. And it's just some kind of iceland and mountains. And here you can see that there's this weird feature that appears that wasn't there before and that seems to change. And they really weren't sure what that could be. So they first checked that it wasn't an artifact of the data, that the data just wasn't saying wrong things, a problem in the instrument, and it wasn't. They're pretty sure this is real. And so maybe they were thinking maybe the water levels are changing and it's really shallow there, so you're seeing something that's below the surface sometime. And that's not true because we have the symmetry, we have the depth of the sea in several places, and this is not that deep there. It is deeper there. And it also doesn't correlate with the sea level change around it. So what's left? Well, it could be things that are changing the surface roughness and making it scatter more towards the radar. So what could do this? Bubbles, waves, and floating solids could do this. So how would the bubbles form? That's actually, recently they found that nitrogen can get dissolved in methane, and a small temperature change in the liquid methane can exhaust the nitrogen and create bubbles that are going to rise to the surface. Now waves are also reasonable because you can have tides and you can have winds and also movements between the different bodies of water that are going to create waves that should be causing this kind of effect. And finally, floating solids would be So they thought of it kind of like ice cubes floating on water, but the problem is that solid methane doesn't form on the surface, it forms on the bottom because it sinks. It's more dense than the liquid methane. However, they think that solid nitrogen could be. And so these are the different hypotheses, and my bet is for waves, but we don't really know. So this is another cool scientific result that they have recently, is that there are canyons. So what they use to prove that there are canyons is the altimetry data. So what does the altimetry do? It looks straight down, and then it sends a radar signal, which is reflected and comes back up, and they measure the amount of time it takes to go down and back up. And from that, you can know what the topography of the landscape is. Now, if you have that, you can know if there's any abrupt change in topography. And indeed, here on the top right, you can see that they see some topography with a sudden, so this is in only one footprint of the altimeter, because the canyons are so narrow that you can't have altimetry over inside of it, when it's all inside of it. So what you see instead is that you get two radar signals from the surroundings, and one much brighter, which is why this is the higher one, from the bottom. But it does take longer to get back. And the reason it's brighter is because there's a liquid at the bottom of the canyon. So what they find is that there are canyons that are up to 570 meters deep and less than 1 kilometer wide, which I think is super cool. And these canyons lead into the seas. So another thing that looks just like Earth is the lakes. There's these lakes that, to me, look exactly like the lakes in Florida. Even though the scale is different, the same processes could be creating similar landscapes. And so the idea here is that these lakes form with sinkholes, and the way sinkholes form is that the rainfall infiltrates into the ground and dissolves the rocks at the bottom, which are limestone in Florida. And this creates caves and springs and sinkholes, and when you create this, the ground can collapse, create a sinkhole, which will fill with water on Earth or methane on Titan, and become a lake. And so the idea is that these lakes could form the same way. And it's actually more complicated than that because it doesn't perfectly match, but this is the leading idea for how these lakes form. And now to my second trivia question. Where are these images from? So here you can choose a line which contains all the correct answers. These are all real images.
Yeah. Right here.
C is correct. There is no comet here because the comets were already talked about. But there is also an image from the surface of the comet, 67 degrees. I just think that's really cool. It's all the images that were taken by landers or rovers from the surface of different planetary bodies in the solar system. So these are all real because we landed on all these different places. And indeed, we landed on Titan. So the Cassini mission had a lander with it, which went through the atmosphere, took a bunch of measurements as it was going down, and then it had parachutes to fall more gently and take a lot of pictures of the surface at amazingly high resolutions. So here you can see pictures of the surface where it landed, and you can see these dendritic channels, these rivers that look just like what you see on Earth. And finally, it landed in a kind of mushy surface, which means it was probably kind of wet. And you can also see in the landscape, it took a picture of where it landed, that there's these big rounded rocks. And these rocks are probably water ice, because water ice behaves like a solid rock on Titan because it's so cold. And the reason they're rounded would be because they're from the river. So if you're in a river, you're going to get erosion by the water or liquid methane going through that's going to make these rounded rocks, which is why this looks just like a riverbed on Earth. And now another cool thing that you have on Titan are cool craters. You have really big ones like Minerva craters, and then slightly smaller one like Simlab crater, which is one of my favorites because it has really good IR data. And there is a really weird mystery about the craters, though, is that almost all the craters are in the equatorial regions. Now, normally you would expect craters to be distributed uniformly over the whole surface. You would expect to see craters in the poles, too. But we don't. So the leading hypothesis there is that maybe the polar regions are just so wet that the craters are eroded really fast. So both through rain and through rivers and maybe moving sediment, and maybe the whole surface is kind of muddy, so the craters don't stay as well when they form. So that would be the hypothesis of why we don't see them in the poles. Another really cool thing you can see on Titan, and this is one of my favorite things, is giant dunes. These are hundreds of miles long, and they're about 1 to 5 kilometers, so let's say a couple miles wide, and they're spaced also by the same width. And so here in white, you see the interdunes, so the space between the dunes, and in dark, those are the dunes. The reason they're dark is because they absorb the material they're made of, hydrocarbons probably, and absorbs the light of the radar. Now, the material they're made of is mostly a mystery. We think it's hydrocarbons because it's absorbing, but we don't really know. So what I like to think of it as is plastic, because plastic is also a hydrocarbon. So I like to think of it as dunes of plastic floating in the tank. And they have other weird mysteries of their composition. It's their orientation. Now, if you look here, north is up, and it looks like the dunes are going to the right. Like if you see how they go around the white things, which are obstacles, like higher topography, it looks like the dunes are propagating to the east. However, all the climate models say that the winds should blow towards the west. Now, dunes should normally propagate in the same direction as the wind because dunes are made of sand, which is carried by wind. And so, how could that be? Now, the first thing you would say is that the climate models are wrong. Well, I don't think they are. I think they're right. So, I don't think that's the solution. The second thing would be that what actually controls the dunes is not the most common winds, but the strongest winds. And that's because strong storms would carry more sand, and so would have more influence on the shape of the dunes. So that's the first hypothesis. The second hypothesis is that the dunes are actually really old and are not active anymore, and when they form, the winds actually blow the other way. It's possible too. I prefer the first hypothesis, but I don't get to decide if it's true. So, yeah, and I worked on the dunes for a while, so my research was all about the dunes and how pretty they are. They're all over, they cover most of the equatorial regions, and they're really cool. Now, let's get to my third trivia question. What are the mountains on Titan named after? Is it after lakes on Earth, planets of Frank Herbert's Dune universe, Titans in the Greek mythology, or mountains in the Lord of the Rings?
In the very back. Yeah, in the very back. D?
D is correct. No. They are named after mountains in the Lord of the Rings. So all of these are other themes of naming elsewhere. So lakes on Earth are used as names for lakes on Titan. So here's Ontario Lacus. Planets of Frank Herbert's Dune universe are names that are used for labyrinth terrains on Titan. So Titan labyrinthus. The labyrinths are really weird terrains that we don't really know how they form or how old they are. I don't really understand them, but they look cool. And Titans in Greek mythology are the theme for Saturn's moons. This one is Enceladus, which is Titan in Greek mythology. And finally, the mountains in the Lord of the Rings are mountains on Titan. So here I also show some hills, which are Lord of the Rings characters. So here you have the Misty Mountains, and you also have Aragorn Mons, and Bilbo Colus and Arwen Colus. Now the mountains, besides having really cool names, are also cool because we don't really understand them. So the big question with the mountains is how did they form? Now on Earth, mountains form with tectonics primarily. You have plate tectonics, and you have volcanoes forming mountains. However, on Titan, we don't think we have plate tectonics. We don't see any evidence for it. the second hypothesis is that Titan slowed down. It originally spun much faster, and now it slowed down so that one face always faces Saturn. Just like the moon always has the same face facing the Earth, Titan always has the same face facing Saturn. So it's possible that it hasn't de-spun that created stress on the surface, which created mountains. But the problem is that neither of these predict the right orientations for the mountains, since all of the mountains have kind of the same orientation on Titan. So they're trying to explain this orientation by saying it's a combination of both, and maybe other processes such as tidal processes caused by tides from Saturn. So they don't really know, which I think is great. I like it when we don't know things. And this is another mountain, which is possibly an ice volcano. And of course, it is named after the most famous volcano in the Lord of the Rings, which is Mount Doom. And we actually have some nice topography there, so we can see that it looks just like what you would expect a volcano to look like. So here I put an example of a volcano in Iceland, which is my favorite volcano because it's the one I study. And it's an eruption, it's a fissure eruption, and it has this, you can see that it has the same topography, the same shape as dune mounds. And also in the radar data of the region, you can see that you have these kind of lobate shapes, which is also what you would expect lava flows to look like. And you would also expect lava flows to be bright and later because they're rough. So it fits the data, but you can't be 100% sure. It could be something else making this. We don't really know. So until we have more data, we cannot confirm that this is a volcano. Also, what is an ice volcano, you may ask? That's an excellent question, because normally we expect volcanoes to spit lava, which are liquid rocks, and not ice. Well, it's because on Titan it's so cold that water ice, is basically a rock, but lower down in the mantle, and lower down in Titan's interior, it's warm enough that water will be liquid. And so, just like lava on Earth, it can reach the surface in a volcano, and you may have a water flow on the surface, which will act similarly to lava on Earth. So that's a possibility. And the next possibility to consider is life on Titan, which probably doesn't look like this, since these people are not wearing spacesuits, and you cannot breathe on Titan, so that's not a good idea. I don't know about the rest. Maybe there are monsters like that. I don't think so. It's highly unlikely. But life on Titan is a possibility. There's two different ways that you could have life on Titan. The first way is that the underground water ocean, that is hundreds of kilometers below the surface, could have life. Just like Enceladus and Europa, which are other moons, also have liquid water oceans under the surface. They may or may not have life in these oceans. We don't really know. There is no way we can know, since we cannot go down there and look. It's possible that if the water from the ocean reaches the surface, we could go examine the water that's reached the surface and see if there's anything that looks like life, which would probably be dead by then, because it's on the surface and it's cold. But it's very hard to know. Now the second possibility, it's even harder to imagine, it's that there would be methane-based life forms on the surface. So on Earth, all life chemistry has to happen inside of water as a solvent. It's possible that instead on Titan, it would happen inside of methane, which is liquid on the surface. Now, the good thing with that, what would lead you to think it's possible, is that there's very complex chemistry on the surface and in the atmosphere, and a lot of organic compounds, many of which are pretty toxic to us, which could be conductive to life, because organic chemistry is good for life. But the people are actually not sure that it's possible to form cell membranes and the right kind of chemical reactions inside of methods. So the only way to know is to go out there and look at what's happening on the surface. So, which is why people have been proposing missions to Titan for a while. Now, which of these options has not been proposed as a Titan mission? A submarine, a rover, a boat, a balloon, or a drone?
Right here.
Nope, submarine has been proposed.
Right here. Rover.
Rover is correct. No one has proposed a rover on Titan. And the reason no one has proposed a rover on Titan is because a rover is not actually a great idea, since we don't know how hard it would be for a rover to walk along. Sorry about that. For a rover to walk along the surface, and especially in the polar regions, which are more interesting because there's liquids. The polar regions, it might be really wet, and so the rover might get stuck. So it wouldn't be a really good idea. Now, the reason people propose a submarine and a boat is because we want to know more about the liquids on Titan, because they're really interesting. And the reason people propose a balloon and a drone is because the very low gravity and very thick atmosphere make it very easy to fly on Titan. And imagine if you were there, you could just like have wings on your arms, you would just flap your wings and you would fly very easily because the atmosphere is so thick and gravity is so small. So, yeah, but the only way to answer all the mysteries I've mentioned is to go out there and explore more. That's the end. Thank you for listening.